We have a serious problem. I've been measuring our speed through space for 4 billion years. These new readings say we're moving 3 times faster than possible.
Oh, fantastic! Now everyone cares about impossible measurements. When I said my surface temperature doesn't make sense, you all called me dramatic. All right, let's focus. Sun, start from the beginning. What speed should we be moving at, and what are these new measurements actually showing?
Do you know the solar system is moving around the galaxy at an incredible speed? Look here. 514,000 miles per hour. At that speed, it takes us 225 million years to complete one lap. We call that a galactic year.
225 million years? The last time we were in this exact spot, dinosaurs were just starting to exist.
That's absolutely wild.
Oh my goodness, I just realized something incredible. We are floating in space. This is unbelievable. How have I not noticed this before?
And in all that time orbiting, I've remained absolutely stunning while you've been dealing with ice ages and asteroid strikes. But please, continue about the speed crisis, darling.
Before we panic, we must understand that speed is always relative. 514,000 miles per hour compared to what exactly? The galaxy center? The cosmic microwave background? Different reference frames give different answers.
Scientists typically measure our motion against the cosmic microwave background, the leftover glow from the Big Bang itself. Because we're moving, one side of the sky appears slightly warmer, the other slightly cooler.
As you can see from the growth metrics, we are performing optimally. Furthermore, our current velocity is exactly 370 kilometers per second. That number has been rock solid for decades.
Okay, so we've established what our speed should be. Now get to the scary part. What did the new measurements show, and why is everyone freaking out about it?
In November 2025, radio telescopes across Europe measured us moving at speed 3.7 times higher than expected. Not a little off, 3.7 times. That shouldn't be physically possible.
3.7 times faster? Faster than the laws of physics allow? Are we about to fly apart? Son, explain how they measured this. What method did they use? Because if this is real, my Earthling's entire understanding of cosmology just got thrown out the window, and I'd like to know why.
The method is actually quite elegant. Scientists count radio galaxies across the sky. As we move through space, it creates a headwind effect, like rain on a moving car. More raindrops hit the front windshield than the back.
They used 3 major radio telescope networks: LOFAR across Europe, NVSS from the United States, and RAX from Australia. By counting radio galaxies in different directions, they detected our cosmic headwind. Here's the problem. If we're moving that much faster than the cosmic microwave background suggests,
then either our galaxy is rotating faster than physics predicts, or something fundamental about the universe's structure is different than we thought.
So you're telling me the universe might not be uniform? That radio galaxies could be clumped unevenly? Or worse, that our entire cosmological model could need revision? This is worse than my atmospheric pressure problems.
The statistical significance was 5.4 sigma. In scientific terms, that means the odds of this being random chance are about 1 in 5 million. This is not a measurement error. This is real.
you know what? I'm not even mad anymore. If the entire standard model of cosmology might be wrong,
then nobody can make fun of my weird measurements ever again.
Right, Pluto? Exactly. They demoted me from planet status in 2006, and I survived.
Science changes when we discover new things. That's literally what makes it awesome. We're witnessing astronomical history.
Based on this data, scientists see two main possibilities. First, radio galaxies might not be distributed as uniformly across the universe as we've assumed. Or second, our fundamental models about cosmic structure need major revisions.
And this isn't even the first weird result. Previous studies using quasars and infrared data found similar unexpectedly strong patterns. Multiple independent measurements are all suggesting something's off with our cosmic models. If this finding holds up under more scrutiny, we could be looking at a fundamental shift in how we understand the universe's large-scale structure.
So while my Earthlings are stuck in traffic complaining about going 30 miles per hour,
we're all hurtling through space at speeds that might literally be rewriting physics textbooks. That's simultaneously terrifying and incredibly cool.
I mean, we've been moving this fast the entire time, and literally nobody noticed until November 2025.
Whether it's 500,000 miles per hour or way faster, we're still here orbiting just fine. The universe isn't going to suddenly realize and stop working. The next generation of radio telescope arrays could help confirm whether this is a cosmic anomaly.
Or if there's some systematic error we haven't identified yet. Based on the rigor of this study, though, systematic error seems less likely.
What fascinates me most is that after billions of years of existence, the universe still has mysteries that can surprise us. We thought we understood our motion through space. Perhaps we were wrong. How wonderfully humbling.
Well, if cosmology is getting a makeover, I vote we also update those unflattering images of my surface.
So here's what we know for certain. Radio telescope measurements published in Physical Review Letters in November 25 found we're moving 3.7 times faster than our cosmic models predict. 5.4 sigma significance means this isn't chance. Either the universe's matter distribution is different than we thought, or something deeper is going on.
But here's the real twist. Even if scientists figure out why we're moving this fast, that just raises more questions. Like, what else about the universe's structure have we gotten wrong? And what other cosmic mysteries are hiding in plain sight, waiting to be discovered?
We got a signal from deep space. Time to solve the mystery of the exoplanet. All right, team, let's get to work.
Sometimes, being the only planet with life makes me feel so alone in the whole galaxy.
That's a signal from an exoplanet, Earth. It could be anything. Don't get your hopes up too fast.
Just because it's a planet doesn't mean it's alive. It's probably just a desolate wasteland, like a cousin of Mars. We have to check its Goldilocks zone. It has to be in that perfect spot that's not too hot and not too cold.
Whoa! It's in the perfect spot. That exoplanet
could actually have liquid oceans. Even if it has water, it could be a runaway greenhouse planet like me, boiling hot. Or an ice cube like Neptune.
Or it could just have frozen water like me. Being in the zone doesn't guarantee liquid. Trust a guy who knows about being dry.
The data says liquid water, atmosphere, and perfect temperature. We found an Earth-like world. I finally have a new buddy.
Well, fine. It's still not as glamorous as me.
And I bet its oceans don't even have perfect tides.
Mystery is solved. You need the Goldilocks zone for liquid water. Finding a planet there means finding a chance for life.
You know what makes me special? I have the coolest moon in the inner solar system. It controls my tides, lights up my nights, and my Earthlings just love staring at it. They even wrote songs about it.
I mean, I'm basically Earth's twin in size and mass. We're neighbors. But somehow I don't have a single moon. Earth never lets me forget it. It's like being the only planet without a +1 to the cosmic dance.
Yeah, tell me about it. I don't have any moons either. At least you're big, Venus. I'm the smallest planet, and everyone just assumes I'm too pathetic to have one. Even Pluto used to have more moons than me, and he's not even a planet anymore.
My moon is so reliable. It's been with me for over 4 billion years. Best cosmic companion ever.
Hey there, Earth. Let's talk about why you two don't have moons. Mercury, buddy, you're in a tough spot that has nothing to do with being pathetic. You see, Mercury, you're so close to the sun and so small that your Hill sphere is absolutely tiny.
What's a Hill sphere?
The Hill sphere is the region where your gravity is the strongest force. Any moon inside that zone will orbit you instead of the sun. And your Hill sphere is only about 175,000 kilometers.
Simply put, Mercury, darling, any moon that tried to orbit you would be like a paper boat in a hurricane. The sun's gravity would just snatch it away faster than you can say orbital mechanics.
You never stood a chance, sweetie.
Okay, but what about me? I'm almost as big as Earth. I'm 80% of Earth's mass. My Hill sphere should be fine, so why am I moonless too?
Oh, Venus, my dear, you're asking the wrong question. Scientists have run simulations, and they suggest something fascinating.
The question isn't why you don't have a moon. It's what happened to the moon you probably once had.
Wait, what? I had a moon? I had a moon and lost it? That's not just embarrassing, that's tragic!
Based on planetary formation models, scientists think that about 4 billion years ago, you got smacked by something huge. The debris from that collision likely formed a moon, just like Earth's. It started orbiting and slowly drifting away, like a normal moon should.
But then, research suggests something catastrophic happened. Roughly 10 million years later, a second massive impact may have struck from the opposite direction. This collision could have slowed your spin, reversed it entirely, and sealed your moon's fate.
When a planet rotates backwards relative to its moon's orbit, tidal forces work in reverse. Instead of pushing the moon away like Earth does, Venus,
you started absorbing your moon's orbital energy. You basically pulled it into a cosmic bear hug of doom.
If this theory is correct, once your moon crossed the Roche limit, your gravity would have torn it to pieces. The debris would have rained down onto your surface over millions of years. Your moon didn't escape, darling. It came home in the most dramatic way possible.
So I didn't just fail to get a moon. According to this theory, I had one, and my backwards rotation destroyed it. That's so much worse than never having one. It's like ghosting your best friend by accidentally crushing them.
Hey, at least we're moonless together, right? I never had a chance because of the sun. You might have lost yours to bad physics. We're like the moonless support group of the inner solar system.
Should we start a club? Mercury's hill sphere is merely 175,000 kilometers. Venus's extends to about 1 million kilometers.
And Earth's reaches 1.5 million kilometers. Distance from the sun is everything, darlings.
You both orbit in the sun's intense gravitational neighborhood.
Mercury never had the mass or distance.
Venus probably had a chance but lost it to catastrophically bad timing. It's not a failure, it's just physics being dramatic as usual.
I'm really sorry for bragging, you two. I didn't know about all this cosmic tragedy. I just got lucky with my distance from the sun and that my moon stuck around after forming. I should have been way more sensitive. I feel like such a jerk now.
Well, if I did lose my moon 4 billion years ago, I'm still here, still the hottest planet, still fabulous. Besides, my thick atmosphere and retrograde rotation make me unforgettable in other ways. Who needs a moon when you've got this personality?
Yeah! And I may be small, but I'm the fastest orbiter and closest to the sun. I survive temperatures that would melt lead.
Who needs a moon when you're basically a speed demon living in an oven? I'm hardcore.
Every planet's story is different, friends. I have 95 moons because I'm massive and far from the sun. You three have your own special circumstances. That's what makes the solar system interesting. If we were all the same, space would be boring.
So basically, Mercury and Venus have no moons because the sun's gravity dominates the inner solar system.
That makes stable moon orbits nearly impossible. Scientific models suggest Venus likely had a moon but may have lost it to reverse tidal forces after a second impact changed its rotation.
Well, I feel better knowing the science behind it. At least if my moon did ditch me, there was a whole cosmic catastrophe involved. 2 giant impacts and backwards physics? That's not just tragic, that's Oscar-worthy drama.
We got a major celestial mystery. Time to solve the sun's secret color.
All right, team, let's get to work.
You look yellow to me, son. Every morning.
And afternoon.
It's just a fact.
Me? Yellow? The ultimate source of all light? How dare you! Look closely, Earth. I emit every color of light at the same intensity. When you mix all colors of light together, what do you get? Pure white.
If you're white, why do I see you as yellow?
Am I colorblind?
That's your fault, Earth. Your beautiful, thick atmosphere is actually acting like a giant color filter.
Me? It's my fault?
Yes, you! Your atmosphere scatters shorter, bluer wavelengths of light. That's why your sky is blue. What's left to reach your surface is the longer, redder, yellower light.
And that's why my thick, glorious atmosphere looks so perfectly orange. It's simply gorgeous.
Wait a minute! That's why the sunsets and sunrises are so red and orange.
Precisely. When my light travels through more of your atmosphere at an angle, even more blue light is scattered away, leaving behind those magnificent reds and oranges. It's all about atmospheric filtering.
So as a summary, the sun is truly white light.
But Earth's atmosphere scatters the blue light everywhere. And that's what's making the sky blue, leaving only the yellow and red light to hit our surface.
That's the secret color of our star.